namely, that they are cocksure, vague, and self-contradictory. It is the business of philosophy to correct these defects so far as it can, without throwing over knowledge altogether. To be a good philosopher, a man must have a strong desire to know, combined with great caution in believing that he knows. He must also have logical acumen and the habit of exact thinking. All of these, of course, are a matter of degree. Vagueness, in particular, belongs in some degree to all human thinking. We can diminish it indefinitely, but we can never abolish it wholly. Philosophy, accordingly, is a continuing activity, not something in which we can achieve final perfection once for all. In this respect, philosophy has suffered from its association with theology. Theological dogmas are fixed and are regarded by the orthodox as incapable of improvement. Philosophers have too often tried to produce similarly final systems. They have not been content with the gradual approximations that satisfied men of science. In this, they seem to me to have been mistaken. Philosophy should be piecemeal and provisional, like science. Final truth belongs to heaven, not to this world. The three defects which I have mentioned are interconnected, and by becoming aware of any one, we may be led to recognize the other two. I will illustrate all three by a few examples. Let us take first the belief in common objects, such as tables and chairs and trees. We all feel quite sure about these in ordinary life, and yet our reasons for confidence are really very inadequate. Naive common sense supposes that they are what they appear to be, but that is impossible, since they do not appear exactly alike to any two simultaneous observers. At least, it is impossible if the object is a single thing, the same for all observers. If we are going to admit that the object is not what we see, we can no longer feel the same assurance that there is an object. This is the first intrusion of doubt. However, we shall speedily recover from this setback and say that, of course, the object is really what physics says it is. Now, physics says that a table or a chair is really an incredibly vast system of electrons and protons in rapid motion, with empty space in between. This is all very well, but the physicist, like the ordinary man, is dependent upon his senses for the existence of the physical world. If you go up to him solemnly and say, "Would you be so kind as to tell me, as a physicist, what a chair really is?" you will get a learned answer. But if you say, without preamble, "Is there a chair there?" he will say, "Of course there is. Can't you see it?" To this, you ought to reply in the negative. You ought to say, "No, I see certain patches of color, but I don't see any electrons and protons, and you tell me that they are what a chair consists of." He may reply, "Yes, but a large number of electrons and protons close together look like a patch of color." "What do you mean by look like?" you will then ask. He is ready with an answer. He means that light waves start from the electrons and protons, or more probably are reflected by them from a source of light, reach the eye, have a series of effects upon the rods and cones, the optic nerve, and the brain, and finally produce a sensation. But he has never seen an eye or an optic nerve or a brain any more than he has seen a chair. He has only seen patches of color, which, he says, are what eyes look like. That is to say, he thinks that the sensation you have when, as you think, you see a chair, has a series of causes, physical and psychological, but all of them, on his own showing, lie essentially and forever outside experience. Nevertheless, he pretends to base his science upon observation. Obviously, there is here a problem for the logician, a problem belonging not to physics, but to quite another kind of study. This is a first example of the way in which the pursuit of precision destroys certainty. The physicist believes that he infers his electrons and protons from what he perceives, but the inference is never clearly set forth in a logical chain, and if it were, it might not look sufficiently plausible to warrant such confidence. In actual fact, The whole development from common sense objects to electrons and protons has been governed by certain beliefs, seldom conscious, but existing in every natural man. These beliefs are not unalterable, but they grow and develop like a tree. We start by thinking that a chair is as it appears to be, and is still there when we are not looking. But we find, by a little reflection, that these two beliefs are incompatible. If the chair is to persist independently of being seen by us, it must be something other than the patch of color we see, because this is found to depend on conditions extraneous to the chair, such as how the light falls, whether we are wearing blue spectacles, and so on. This forces the man of science to regard the real chair as the cause, or an indispensable part of the cause, of our sensations when we see the chair. Thus, we are committed to causation as an a priori belief, without which we should have no reason for supposing that there is a real chair at all. Also, for the sake of permanence, we bring in the notion of substance. The real chair is a substance, or collection of substances, possessed of permanence and the power to cause sensations. This metaphysical belief has operated more or less unconsciously in the inference from sensations to electrons and protons. The philosopher must drag such beliefs into the light of day and see whether they still survive. Often it will be found that they die on exposure. Let us now take up another point. The evidence for a physical law, or for any scientific law, always involves both memory and testimony. We have to rely both upon what we remember to have observed on former occasions, and on what others say they have observed. In the very beginnings of science, it may have been possible sometimes to dispense with testimony, but very soon every scientific investigation began to be built upon previously ascertained results, and thus to depend upon what others had recorded. In fact, without the corroboration of testimony, we should hardly have had much confidence in the existence of physical objects. Sometimes people suffer from hallucinations, that is to say, they think they perceive physical objects, but are not confirmed in this belief by the testimony of others. In such cases, we decide that they are mistaken. It is the similarity between the perceptions of different people in similar situations that makes us feel confident of the external causation of our perceptions. But for this, whatever naive beliefs we might have had in physical objects would have been dissipated long ago. Thus, memory and testimony are essential to science. Nevertheless, each of these is open to criticism by the skeptic. Even if we succeed, more or less, in meeting his criticism, we shall, if we are rational, be left with a less complete confidence in our original beliefs than we had before. Once more, we shall become less cocksure as we become more accurate. Both memory and testimony lead us to behavioral psychology. I shall not at this stage discuss either beyond the point at which it is clear that there are genuine philosophical problems to be solved. I shall begin with memory. Memory is a word which has a variety of meanings. The kind that I am concerned with at the moment is the recollection of past occurrences. This is so notoriously fallible that every experimenter makes a record of the result of his experiment at the earliest possible moment. He considers the inference from written words to past events less likely to be mistaken than the direct beliefs which constitute memory. But some time, though perhaps only a few seconds, must elapse between the observation and the making of the record, unless the record is so fragmentary that memory is needed to interpret it. Thus, we do not escape from the need of trusting memory to some degree. Moreover, without memory, we should not think of interpreting records as applying to the past, because we should not know that there was any past. Now, apart from arguments as to the proved fallibility of memory, there is one awkward consideration which the skeptic may urge. Remembering, which occurs now, cannot possibly, he may say, prove that what is remembered occurred at some other time, because the world might have sprung into being 5 minutes ago, exactly as it then was, full of acts of remembering which are entirely misleading. Opponents of Darwin, such as Edmund Buss's father, urged a very similar argument against evolution. The world, they said, was created in 4004 BC, complete with fossils, which were inserted to try our faith. The world was created suddenly, but it was made such as it would have been if it had evolved. There is no logical impossibility about this view, and similarly, there is no logical impossibility in the view that the world was created 5 minutes ago, complete with memories and records. This may seem an improbable hypothesis, but it is not logically refutable. Apart from this argument, which may be thought fantastic, there are reasons of detail for being more or less distrustful of memory. It is obvious that no direct confirmation of a belief about a past occurrence is possible, because we cannot make the past recur. We can find confirmation of an indirect kind in the revelation of others and in contemporary records. The latter, as we have seen, involve some degree of memory, but they may involve very little. For instance, when a shorthand report of a conversation or speech has been made at the time. But even then, we do not escape wholly from the need of memory extending over a longer stretch of time. Suppose a wholly imaginary conversation were produced for some criminal purpose. We should depend upon the memories of witnesses to establish its fictitious character in a law court. And all memory which extends over a long period of time is very apt to be mistaken. This is shown by the errors invariably found in autobiographies. Any man who comes across letters which he wrote many years ago can verify the manner in which his memory has falsified past events. For these reasons, the fact that we cannot free ourselves from dependence upon memory in building up knowledge is prima facie a reason for regarding what passes for knowledge as not quite certain. The whole of this subject of memory will be considered more carefully in later chapters. Testimony raises even more awkward problems. What makes them so awkward is the fact that testimony is involved in building up our knowledge of physics, and that, conversely, physics is required in establishing the trustworthiness of testimony. Moreover, testimony raises all the problems connected with the relation of mind and matter. Some eminent philosophers, e.g. Leibniz, have constructed systems according to which there would be no such thing as testimony, and yet have accepted as true many things which cannot be known without it. I do not think philosophy has quite done justice to this problem, but a few words will, I think, show its gravity. For our purposes, we may define testimony as noises heard or shapes seen, analogous to those which we should make if we wish to convey an assertion, and believed by the hearer or seer to be due to someone else's desire to convey an assertion. Let us take a concrete instance. I ask a policeman the way, and he says, "Fourth turn to the right, third to the left." That is to say, I hear these sounds, and perhaps I see what I interpret as his lips moving. I assume that he has a mind more or less like my own, and has uttered these sounds with the same intention as I should have if I had uttered them, namely to convey information. In ordinary life, all this is not, in any proper sense, an inference. It is a belief which arises in us on the appropriate occasion. But if we are challenged, we have to substitute inference for spontaneous belief, and the more the inference is examined, the more shaky it looks. The inference that has to be made has two steps, one physical and one psychological. The physical inference is of the sort we considered a moment ago, in which we pass from a sensation to a physical occurrence. We hear noises and think they proceed from the policeman's body. We see moving shapes and interpret them as physical motions of his lips. This inference, as we saw earlier, is in part justified by testimony. Yet now we find that it has to be made before we can have reason to believe that there is any such thing as testimony. And this inference is certainly sometimes mistaken. Lunatics hear voices which other people do not hear. Instead of crediting them with abnormally acute hearing, we lock them up. But if we sometimes hear sentences which have not proceeded from a body, why should this not always be the case? Perhaps our imagination has conjured up all the things that we think others have said to us. But this is part of the general problem of inferring physical objects from sensations, which, difficult as it is not the most difficult part of the logical puzzles concerning testimony. The most difficult part is the inference from the policeman's body to his mind. I do not mean any special insult to policemen. I would say the same of politicians and even of philosophers. The inference to the policeman's mind certainly may be wrong. It is clear that a maker of waxworks could make a lifelike policeman and put a gramophone inside him, which would cause him, periodically, to tell visitors the way to the most interesting part of the exhibition at the entrance to which he would stand. They would have just the sort of evidence of his being alive that is found convincing in the case of other policemen. Descartes believed that animals have no minds, but are merely complicated automata. 18th century materialists extended this doctrine to men, but I am not now concerned with materialism. My problem is a different one. Even a materialist must admit that when he talks, he means to convey something. That is to say, he uses words as signs, not as mere noises. It may be difficult to decide exactly what is meant by this statement, but it is clear that it means something, and that it is true of one's own remarks. The question is, are we sure that it is true of the remarks we hear, as well as of those we make? Or are the remarks we hear perhaps just like other noises, merely meaningless disturbances of the air? The chief argument against this is analogy. The remarks we hear are so like those we make that we think they must have similar causes. But although we cannot dispense with analogy as a form of inference, it is by no means demonstrative, and not infrequently leads us astray. We are therefore left, once more, with a prima facie reason for uncertainty and doubt. This question of what we mean ourselves when we speak brings me to another problem, that of introspection. Many philosophers have held that introspection gave the most indubitable of all knowledge. Others have held that there is no such thing as introspection. Descartes, after trying to doubt everything, arrived at I think, therefore I am, as a basis for the rest of knowledge. Dr. John B. Watson, the behavioralist, holds, on the contrary, that we do not think, but only talk. Dr. Watson, in real life, gives as much evidence of thinking as anyone does, so if he is not convinced that he thinks, we are all in a bad way. At any rate, the mere existence of such an opinion as his, on the part of a competent philosopher, must suffice to show that introspection is not so certain as some people have thought. But let us examine this question a little more closely. The difference between introspection and what we call perception of external objects seems to me to be connected, not with what is primary in our knowledge, but with what is inferred. We think, at one time, that we are seeing a chair, at another, that we are thinking about philosophy. The first we call perception of an external object. The second we call introspection. Now, we have already found reason to doubt external perception in the full-blooded sense in which common sense accepts it. I shall consider later what there is that is indubitable and primitive in perception. For the moment, I shall anticipate by saying that what is indubitable in seeing a chair is the occurrence of a certain pattern of colors. But this occurrence, we shall find, is connected with me just as much as with the chair. No one except myself can see exactly the pattern that I see. There is thus something subjective and private about what we take to be external perception, but this is concealed by precarious extensions into the physical world. I think introspection, on the contrary, involves precarious extensions into the mental world. Short of these, it is not very different from external perception, short of its extensions. To make this clear, I shall try to show what we know to be occurring when, as we say, we think about philosophy. Suppose, as the result of introspection, you arrive at a belief which you express in the words, I am now believing that mind is different from matter. What do you know, apart from inferences, in such a case? First of all, you must cut out the word I. The person who believes is an inference, not part of what you know immediately. In the second place, you must be careful about the word believing. I am not now concerned with what this word should mean in logic or theory of knowledge. I am concerned with what it can mean when used to describe a direct experience. In such a case, it would seem that it can only describe a certain kind of feeling. And as for the proposition you think you are believing, namely, mind is different from matter, it is very difficult to say what is really occurring when you think you believe it. It may be mere words, pronounced, visualized, or in auditory or motor images. It may be images of what the words mean, but in that case it will not be at all an accurate representation of the logical content of the proposition. You may have an image of a statue of Newton voyaging through strange seas of thought alone, and another image of a stone rolling downhill, combined with the words, "How different!" Or you may think of the difference between composing a lecture and eating your dinner. It is only when you come to expressing your thought in words that you approach logical precision. Both in introspection and in external perception, we try to express what we know in words. We come here, as in the question of testimony, upon the social aspect of knowledge. The purpose of words is to give the same kind of publicity to thought as is claimed for physical objects. A number of people can hear a spoken word or see a written word, because each is a physical occurrence. If I say to you, mind is different from matter, there may be only a very slight resemblance between the thought that I am trying to express and the thought which is aroused in you. But these two thoughts have just this in common, that they can be expressed by the same words. Similarly, there may be great differences between what you and I see when, as we say, we look at the same chair. Nevertheless, we can both express our perceptions by the same words. A thought and a perception are thus not so very different in their own nature. If physics is true, they are different in their correlations. When I see a chair, others have more or less similar perceptions, and it is thought that these are all connected with the light waves coming from the chair. Whereas, when I think of thought, others may not be thinking anything similar. But this applies also to feeling a toothache, which would not usually be regarded as a case of introspection. On the whole, therefore, there seems no reason to regard introspection as a different kind of knowledge from external perception. But this whole question will concern us again at a later stage. As for the trustworthiness of introspection, there is again a complete parallelism with the case of external perception. The actual datum in each case is unimpeachable, but the extensions which we make instinctively are questionable. Instead of saying, I am believing that mind is different from matter, you ought to say, certain images are occurring in a certain relation to each other, accompanied by a certain feeling. No words exist for describing the actual occurrence in all its particularity. All words, even proper names, are general, with the possible exception of this, which is ambiguous. When you translate the occurrence into words, you are making generalizations and inferences, just as you are when you say, there is a chair. There is really no vital difference between the two cases. In each case, what is really a datum is unutterable, and what can be put into words involves inferences which may be mistaken. When I say that inferences are involved, I am saying something not quite accurate unless carefully interpreted. In seeing a chair, for instance, we do not first apprehend a colored pattern and then proceed to infer a chair. Belief in the chair arises spontaneously when we see the colored pattern. But this belief has causes not only in the present physical stimulus, but also partly in past experience, partly in reflexes. In animals, reflexes play a very large part. In human beings, experience is more important. The infant learns slowly to correlate touch and sight. and to expect others to see what he sees. The habits which are thus formed are essential to our adult notion of an object, such as a chair. The perception of a chair by means of sight has a physical stimulus which affects only sight directly, but stimulates ideas of solidity, and so on through early experience. The inference might be called physiological. An inference of this sort is evidence of past correlations, for instance between touch and sight, but may be mistaken in the present instance. You may, for instance, mistake a reflection in a large mirror for another room. Similarly, in dreams we make mistaken physiological inferences. We cannot therefore feel certainty in regard to things which are, in this sense, inferred, because when we try to accept as many of them as possible, we are nevertheless compelled to reject some for the sake of self-consistency. We arrived a moment ago at what we called physiological inference as an essential ingredient in the common sense notion of a physical object. Physiological inference, in its simplest form, means this. Given a stimulus, S, to which by a reflex we react by a bodily movement, R, and a stimulus S prime with a reaction R prime, if the two stimuli are frequently experienced together, S will in time produce R prime. Footnote, e.g., if you hear a sharp noise and see a bright light simultaneously often, in time the noise without the light will cause your pupils to contract. End footnote. That is to say, the body will act as if S prime were present. Physiological inference is important in theory of knowledge, and I shall have much to say about it at a later stage. For the present, I have mentioned it partly to prevent it from being confused with logical inference, and partly in order to introduce the problem of induction, about which we must say a few preliminary words at this stage. Induction raises perhaps the most difficult problem in the whole theory of knowledge. Every scientific law is established by its means, and yet it is difficult to see why we should believe it to be a valid logical process. Induction, in its bare essence, consists of the argument that because A and B have been often found together and never found apart, therefore, when A is found again, B will probably also be found. This exists first as a physiological inference, and as such is practiced by animals. When we first begin to reflect, we find ourselves making inductions in the physiological sense. For instance, expecting the food we see to have a certain kind of taste. Often we only become aware of this expectation through having it disappointed. For instance, if we take salt, thinking it is sugar. When mankind took to science, they tried to formulate logical principles justifying this kind of inference. I shall discuss these attempts in later chapters. For the present, I will only say that they seem to me very unsuccessful. I am convinced that induction must have validity of some kind in some degree, but the problem of showing how or why it can be valid remains unsolved. Until it is solved, the rational man will doubt whether his food will nourish him and whether the sun will rise tomorrow. I am not a rational man in this sense, but for the moment I shall pretend to be. And even if we cannot be completely rational, we should probably all be the better for becoming somewhat more rational than we are. At the lowest estimate, it will be an interesting adventure to see whither reason will lead us. The problems we have been raising are none of them new, but they suffice to show that our everyday views of the world and of our relations to it are unsatisfactory. We have been asking whether we know this or that, but we have not yet asked what knowing is. Perhaps we shall find that we have had wrong ideas as to knowing, and that our difficulties grow less when we have more correct ideas on this point. I think we shall do well to begin our philosophical journey by an attempt to understand knowing considered as part of the relation of man to his environment, forgetting, for the moment, the fundamental doubts with which we have been concerned. Perhaps modern science may enable us to see philosophical problems in a new light. In that hope, let us examine the relation of man to his environment with a view to arriving at a scientific view as to what constitutes knowledge. End of chapter 1. Chapter 2 of Philosophy by Bertrand Russell. The Sleepybox recordings in the public domain. Part 1. Man from Without. Chapter 2. Man and his environment. If our scientific knowledge were full and complete, we should understand ourselves and the world and our relation to the world. As it is, our understanding of all three is fragmentary. For the present, it is the third question, that of our relation to the world, that I wish to consider, because this brings us nearest to the problems of philosophy. We shall find that it will lead us back to the two other questions, as to the world and as to ourselves, but that we shall understand both these better if we have considered first how the world acts upon us, and how we act upon the world. There are a number of sciences which deal with man. We may deal with him in natural history, as one among the animals, having a certain place in evolution, and related to other animals in ascertainable ways. We may deal with him in physiology, as a structure capable of performing certain functions, and reacting to the environment in ways of which some, at least, can be explained by chemistry. We may study him in sociology, as a unit in various organisms, such as the family and the state. And we may study him in psychology as he appears to himself. This last gives what we may call an internal view of man, as opposed to the other three, which give an external view. That is to say, in psychology we use data which can only be obtained when the observer and the observed are the same person, whereas in the other ways of studying man, all our data can be obtained by observing other people. There are different ways of interpreting this distinction, and different views of its importance, but there can be no doubt that there is such a distinction. We can remember our own dreams, whereas we cannot know the dreams of others unless they tell us about them. We know when we have toothache, when our food tastes too salty, when we are remembering some past occurrence, and so on. All these events in our lives, other people cannot know in the same direct way. In this sense, we have an inner life, open to our own inspection, but no one else's. This is no doubt the source of the traditional distinction of mind and body. The body was supposed to be that part of us which others could observe, and the mind that part which was private to ourselves. The importance of the distinction has been called in question in recent times, and I do not myself believe that it has any fundamental philosophical significance. But historically it has played a dominant part in determining the conceptions from which men set out when they began to philosophize, and on this account, if on no other, it deserves to be borne in mind. Knowledge, traditionally, has been viewed from within, as something which we can observe in ourselves, rather than as something which we can see others displaying. When I say that it has been so viewed, I mean that this has been the practice of philosophers. In ordinary life, people have been more objective. In ordinary life, knowledge is something which can be tested by examinations. That is to say, it consists in a certain kind of response to a certain kind of stimulus. This objective way of viewing knowledge is, to my mind, much more fruitful than the way which has been customary in philosophy. I mean that if we wish to give a definition of knowing, we ought to define it as a manner of reacting to the environment, not as involving something, a state of mind, which only the person who has the knowledge can observe. It is because I hold this view that I think it best to begin with man and his environment, rather than with those matters in which the observer and the observed must be the same person. Knowing, as I view it, is a characteristic which may be displayed in our reactions to our environment. It is therefore necessary, first of all, to consider the nature of these reactions as they appear in science. Let us take some everyday situation. Suppose you are watching a race, and at the appropriate moment you say, "They're off." This exclamation is a reaction to the environment, and is taken to show knowledge if it is made at the same time as others make it. Now let us consider what has really been happening according to science. The complication of what has happened is almost incredible. It may conveniently be divided into four stages. First, what happened in the outside world between the runners in your eyes. Secondly, what happened in your body from your eyes to your brain. Thirdly, what happened in your brain. Fourthly, what happened in your body from your brain to the movements of your throat and tongue, which constituted your exclamation. Of these four stages, the first belongs to physics and is dealt with in the main by the theory of light. The second and fourth belong to physiology. The third, though it should theoretically also belong to physiology, belongs in fact rather to psychology, owing to our lack of knowledge as to the brain. The third stage embodies the results of experience and learning. It is responsible for the fact that you speak, which an animal would not do, and that you speak English, which a Frenchman would not do. This immensely complicated occurrence is, nevertheless, about the simplest example of knowledge that could possibly be given. For the moment, let us leave on one side the part of this process which happens in the outside world and belongs to physics. I shall have much to say about it later, but what has to be said is not altogether easy, and we will take less abstruse matters first. I will merely observe that the event which we are said to perceive, namely the runner starting, is separated by a longer or shorter chain of events from the event which happens at the surface of our eyes. It is this last that is what is called the stimulus. Thus, the event that we are said to perceive when we see is not the stimulus, but an anterior event related to it in a way that requires investigation. The same applies to hearing and smell, but not to touch or to the perception of states of our own body. In these cases, the first of the above four stages is absent. It is clear that in the case of sight, hearing, and smell, there must be a certain relation between the stimulus and the event said to be perceived, but we will not now consider what this relation must be. We will consider, rather, the second, third, and fourth stages in an act of perceptive knowledge. This is the more legitimate, as these stages always exist, whereas the first is confined to certain senses. The second stage is that which proceeds from the sense organ to the brain. It is not necessary, for our purposes, to consider exactly what goes on during this journey. A purely physical event, the stimulus, happens at the boundary of the body and has a series of effects which travel along the afferent nerves to the brain. If the stimulus is light, it must fall on the eye to produce the characteristic effects. No doubt light falling on other parts of the body has effects, but they are not those that distinguish vision. Similarly, if the stimulus is sound, it must fall on the ear. A sense organ, like the photographic plate, is responsive to stimuli of a certain sort. Light falling on the eye has effects which are different for different wavelengths, intensities, and directions. When the events in the eye due to incident light have taken place, they are followed by events in the optic nerve, leading at last to some occurrence in the brain, an occurrence which varies with the stimulus. The occurrence in the brain must be different for different stimuli in all cases where we can perceive differences. Red and yellow, for instance, are distinguishable in perception. Therefore, the occurrences along the optic nerve and in the brain must have a different character when caused by red light from what they have when caused by yellow light. But when two shades of color are so similar that they can only be distinguished by delicate instruments, not by perception, we cannot be sure that they cause occurrences of different characters in the optic nerve and brain. When the disturbance has reached the brain, it may or may not cause a characteristic set of events in the brain. If it does not, we shall not be what is called conscious of it. For to be conscious of seeing yellow, whatever else it may be, must certainly involve some kind of cerebral reaction to the message brought by the optic nerve. It may be assumed that the great majority of messages brought to the brain by the afferent nerves never secure any attention at all. They are like letters to a government office which remain unanswered. The things in the margin of the field of vision, unless they are in some way interesting, are usually unnoticed. If they are noticed, They are brought into the center of the field of vision unless we make a deliberate effort to prevent this from occurring. These things are visible in the sense that we could be aware of them if we chose, without any change in our physical environment or in our sense organs. That is to say, only a cerebral change is required to enable them to cause a reaction. But usually they do not provoke any reaction. Life would be altogether too wearing if we had to be always reacting to everything in the field of vision. Where there is no reaction, the second stage completes the process, and the third and fourth stages do not arise. In that case, there has been nothing that could be called perception connected with the stimulus in question. To us, however, the interesting case is that in which the process continues. In this case, there is first a process in the brain, of which the nature is as yet conjectural, which travels from the center appropriate to the sense in question to a motor center. From these, there is a process which travels along an efferent nerve, and finally results in a muscular event causing some bodily movement. In our illustration of the man watching the beginning of a race, a process travels from the part of the brain concerned with sight to the part concerned with speech. This is what we call the third stage. Then a process travels along the efferent nerves and brings about the movements which constitute saying, "They're off." This is what we call the fourth stage. Unless all four stages exist, there is nothing that can be called knowledge. And even when they are all present, various further conditions must be satisfied if there is to be knowledge. But these observations are premature, and we must return to the analysis of our third and fourth stages. The third stage is of two sorts, according as we are concerned with a reflex or with a learned action, as Dr. Watson calls it. In the case of a reflex, if it is complete at birth, a newborn infant or animal has a brain so constituted that, without the need of any previous experience, there is a connection between a certain process in the afferent nerves and a certain other process in the efferent nerves. A good example of a reflex is sneezing. A certain kind of tickling in the nose produces a fairly violent movement having a very definite character, and this connection exists already in the youngest infants. Learned reactions, on the other hand, are such as only occur because of the effect of previous occurrences in the brain. One might illustrate by an analogy, which, however, would be misleading if pressed. Imagine a desert in which no rain has ever fallen, and suppose that at last a thunderstorm occurs in it. Then the course taken by the water will correspond to a reflex. But if rain continues to fall frequently, it will form watercourses and river valleys. When this has occurred, the water runs away along preformed channels, which are attributable to the past experience of the region. This corresponds to learned reactions. One of the most notable examples of learned reactions is speech. We speak because we have learned a certain language, not because our brain had originally any tendency to react in just that way. Perhaps all knowledge, certainly nearly all, is dependent upon learned reactions, i.e., upon connections in the brain which are not part of man's congenital equipment, but are the result of events which have happened to him. To distinguish between learned and unlearned responses is not always an easy task. It cannot be assumed that responses which are absent during the first weeks of life are all learned. To take the most obvious instance, sexual responses change their character to a greater or less extent at puberty, as a result of changes in the ductless glands, not as a result of experience. But this instance does not stand alone. As the body grows and develops, new modes of response come into play, modified, no doubt, by experience, but not wholly due to it. For example, a newborn baby cannot run, and therefore does not run away from what is terrifying, as an older child does. The older child has learned to run, but has not necessarily learned to run away. The stimulus in learning to run may have never been a terrifying object. It would therefore be a fallacy to suppose that we can distinguish between learned and unlearned responses by observing what a newborn infant does, since reflexes may come into play at a later stage. Conversely, some things which a child does at birth may have been learned, when they are such as it could have been done in the womb. For example, a certain amount of kicking and stretching. The whole distinction between learned and unlearned responses, therefore, is not so definite as we could wish. At the two extremes we get clear cases, such as sneezing on the one hand and speaking on the other, but there are intermediate forms of behavior which are more difficult to classify. This is not denied even by those who attach most importance to the distinction between learned and unlearned responses. In Dr. Watson's Behaviorism, page 103, there is a summary of unlearned equipment, which ends with the following paragraph. Other activities appear at a later stage, such as blinking, reaching, handling, handedness, crawling, standing, sitting up, walking, running, jumping. In the great majority of these later activities, it is difficult to say how much of the act as a whole is due to training or conditioning. A considerable part is unquestionably due to the growth changes in structure, and the remainder is due to training and conditioning. It is not possible to make a logically sharp distinction in this matter. In certain cases, we have to be satisfied with something less exact. For example, we might say that those developments which are merely due to normal growth are to count as unlearned, while those which depend upon special circumstances in the individual biography are to count as learned. But take, say, muscular development. This will not take place normally unless the muscles are used, and if they are used, they are bound to learn some of the skill which is appropriate to them. And some things which must certainly count as learned, such as focusing with the eyes, depend upon circumstances which are normal and must be present in the case of every child who is not blind. The whole distinction, therefore, is one of degree rather than of kind. Nevertheless, it is valuable. The value of the distinction between learned and unlearned reaction is connected with the laws of learning, to which we shall come in the next chapter. Experience modifies behavior according to certain laws, and we may say that a learned reaction is one in the formation of which these laws have played a part. For example, children are frightened of loud noises from birth, but are not at first frightened of dogs. After they have heard a dog barking loudly, they may become frightened of dogs, which is a learned reaction. If we knew enough about the brain, we could make the distinction precise by saying that learned reactions are those depending upon modifications of the brain other than mere growth. But as it is, we have to judge by observations of bodily behavior, and the accompanying modifications in the brain are assumed on a basis of theory rather than actually observed. The essential points, for our purposes, are comparatively simple. Man, or any other animal at birth, is such as to respond to certain stimuli in certain specific ways, i.e., by certain kinds of bodily movements. As he grows, these ways of responding change, partly as the mere result of developing structure, partly in consequence of events in his biography. The latter influence proceeds according to certain laws, which we shall consider, since they have much to do with the genesis of knowledge. But, the indignant reader may be exclaiming, knowing something is not a bodily movement, but a state of mind, and yet you talk to us about sneezing in such matters. I must ask the indignant reader's patience. He knows that he has states of mind, and that his knowing is itself a state of mind. I do not deny that he has states of mind, but I ask two questions. First, what sort of thing are they? Secondly, what evidence can he give me that he knows about them? The first question he may find very difficult, and if he wants, in his answer, to show that states of mind are something of a sort totally different from bodily movements, he will have to tell me also what bodily movements are, which will plunge him into the most abstruse part of physics. All this I propose to consider later on, and then I hope the indignant reader will be appeased. As to the second question, namely, what evidence of his knowledge another man can give me, it is clear that he must depend upon speech or writing, i.e., in either case, upon bodily movements. Therefore, whatever knowledge may be to the knower, as a social phenomenon, it is something displayed in bodily movements. For the present, I am deliberately postponing the question of what knowledge is to the knower, and confining myself to what it is for the external observer. And for him, necessarily, it is something shown by bodily movements made in answer to stimuli, more specifically, to examination questions. What else it may be, I shall consider at a later stage. However, we may subsequently add to our present account by considering how knowledge appears to the knower, that will not invalidate anything that we may arrive at by considering how knowledge appears to the external observer. And there is something which it is important to realize, namely, that we are concerned with a process in which the environment first acts upon a man, and then he reacts upon the environment. This process has to be considered as a whole if we are to discuss what knowledge is. The older view would have been that the effect of the environment upon us might constitute a certain kind of knowledge, perception, while our reaction to the environment constituted volition. These were, in each case, mental occurrences, and their connection with nerves and brain remained entirely mysterious. I think the mystery can be eliminated, and the subject removed from the realm of guesswork by starting with the whole cycle, from stimulus to bodily movement. In this way, knowing becomes something active, not something contemplative. Knowing and willing, in fact, are merely aspects of the one cycle, which must be considered in its entirety if it is to be rightly understood. A few words must be said about the human body as a mechanism. It is an inconceivably complicated mechanism, and some men of science think that it is not explicable in terms of physics and chemistry, but is regulated by some vital principle, which makes its laws different from those of dead matter. These men are called vitalists. I do not myself see any reason to accept their view, but at the same time, our knowledge is not sufficient to enable us to reject it definitely. What we can say is that their case is not proved, and that the opposite view is, scientifically, a more fruitful working hypothesis. It is better to look for physical and chemical explanations where we can, since we know of many processes in the human body which cannot be accounted for in this way, and of none which certainly cannot. To invoke a vital principle is to give an excuse for laziness, when perhaps more diligent research would have enabled us to do without it. I shall therefore assume, as a working hypothesis, that the human body acts according to the same laws of physics and chemistry as those which govern dead matter, and that it differs from dead matter not by its laws, but by the extraordinary complexity of its structure. The movements of the human body may nonetheless be divided into two classes, which we may call respectively mechanical and vital. As an example of the former, I should give the movements of a man falling from a cliff into the sea. To explain this, in its broad features, it is not necessary to take account of the fact that the man is alive. His center of gravity moves exactly as that of a stone would move. But when a man climbs up a cliff, he does something that dead matter, of the same shape and weight, would never do. This is a vital movement. There is in the human body a lot of stored chemical energy in more or less unstable equilibrium. A very small stimulus can release this energy and cause a considerable amount of bodily movement. The situation is analogous to that of a large rock delicately balanced on the top of a conical mountain. A tiny shove may send it thundering down into the valley, in one direction or another, according to the direction of the shove. So if you say to a man, "Your house is on fire," he will start running. Although the stimulus contained very little energy, his expenditure of energy may be tremendous. He increases the available energy by panting, which makes his body burn up faster and increases the energy due to combustion. This is just like opening the draft in a furnace. Vital movements are those that use up this energy which is in unstable equilibrium. It is they alone that concern the biochemist, the physiologist, and the psychologist. The others, being just like the movements of dead matter, may be ignored when we are especially concerned with the study of man. Vital movements have a stimulus which may be inside or outside the body, or both at once. Hunger is a stimulus inside the body, but hunger combined with the sight of good food is a double stimulus, both internal and external. The effect of a stimulus may be, in theory, according to the laws of physics and chemistry, but in most cases this is, at present, no more than a pious opinion. What we know from observation is that behavior is modified by experience. That is to say, that if similar stimuli are repeated in intervals, they produce gradually changing reactions. When a bus conductor says, "Fares, please," a very young child has no reaction. An older child gradually learns to look for pennies, and if a male, ultimately acquires the power of producing the requisite sum on demand without conscious effort. The way in which our reactions change with experience is a distinctive characteristic of animals. Moreover, it is more marked in the higher than in the lower animals, and most marked of all in man. It is a matter intimately connected with intelligence, and must be investigated before we can understand what constitutes knowledge from the standpoint of the external observer. We shall be concerned with it at length in the next chapter. Speaking broadly, the actions of all living things are such as tend to biological survival, i.e., to the leaving of a numerous progeny. But when we descend to the lowest organisms, which have hardly anything that can be called individuality, and reproduce themselves by fission, it is possible to take a simpler view. Living matter, within limits, has the chemical peculiarity of being self-perpetuating, and of conferring its own chemical composition upon other matter composed of the right elements. One spore falling into a stagnant pond may produce millions of minute vegetable organisms. These, in turn, enable one small animal to have myriads of descendants living on the small plants. These, in turn, provide life for larger animals, newts, tadpoles, fishes, etc. In the end, there is enormously more protoplasm in that region than there was to begin with. This is no doubt explicable as a result of the chemical constitution of living matter, but this purely chemical self-preservation and collective growth is at the bottom of everything else that characterizes the behavior of living things. Every living thing is a sort of imperialist, seeking to transform as much as possible of its environment into itself and its seed. The distinction between self and posterity is one which does not exist in a developed form in asexual, unicellular organisms. Many things, even in human life, can only be completely understood by forgetting it. We may regard the whole of evolution as flowing from this chemical imperialism of living matter. Of this, man is only the last example, so far. He transforms the surface of the globe by irrigation, cultivation, mining, quarrying, making canals and railways, breeding certain animals and destroying others. And when we ask ourselves, from the standpoint of an outside observer, what is the end achieved by all these activities, we find that it can be summed up in one very simple formula: to transform as much as possible of the matter on the Earth's surface into human bodies. Domestication of animals, agriculture, commerce, industrialism have been stages in this process. When we compare the human population of the globe with that of other large animals, and also with that of former times, we see that chemical imperialism has been, in fact, the main end to which human intelligence has been devoted. Perhaps intelligence is reaching the point where it can conceive worthier ends, concerned with the quality rather than the quantity of human life. But as yet, such intelligence is confined to minorities, and does not control the great movements of human affairs. Whether this will ever be changed, I do not venture to predict. And in pursuing the simple purpose of maximizing the amount of human life, we have, at any rate, The consolation of feeling at one with the whole movement of living things from their earliest origin on this planet. End of chapter 2. Chapter 3 of Philosophy by Bertrand Russell. The Sleeper-Box recording is in the public domain. The process of learning in animals and infants. In the present chapter, I wish to consider the processes by which, and the laws according to which, an animal's original repertoire of reflexes is changed into a quite different set of habits as a result of events that happen to it. A dog learns to follow his master in preference to anyone else. A horse learns to know his own stall in the stable. A cow learns to come to the cowshed at milking time. All these are acquired habits, not reflexes. They depend upon the circumstances of the animals concerned, not merely upon the congenital characteristics of the species. When I speak of an animal learning something, I shall include all cases of acquired habits, whether or not they are useful to the animal. I have known horses in Italy learn to drink wine, which I cannot believe to have been a desirable habit. A dog may learn to fly at a man who has ill-treated it, and may do so with such regularity and ferocity as to lead to its being killed. I do not use learning in any sense involving praise, but merely to denote modification of behavior as the result of experience. The manner in which animals learn has been much studied in recent years, with a great deal of patient observation and experiment. Certain results have been obtained as regards the kinds of problems that have been investigated, but on general principles there is still much controversy. One may say broadly that all the animals that have been carefully observed have behaved so as to confirm the philosophy in which the observer believed before his observations began. Nay, more, they have all displayed the national characteristics of the observer. Animals studied by Americans rush about frantically, with an incredible display of hustle and pep, and at last achieve the desired result by chance. Animals observed by Germans sit still and think, and at last evolve the solution out of their inner consciousness. To the plain man, such as the present writer, this situation is discouraging. I observe, however, that the type of problem which a man naturally sets to an animal depends upon his own philosophy, and that this probably accounts for the differences in the results. The animal responds to one type of problem in one way, and to another in another. Therefore, the results obtained by different investigators, though different, are not incompatible. But it remains necessary to remember that no one investigator is to be trusted to give a survey of the whole field. The matters with which we shall be concerned in this chapter belong to behaviorist psychology, and in part to pure physiology. Nevertheless, they seem to me vital to a proper understanding of philosophy, since they are necessary for an objective study of knowledge and inference. I mean by an objective study, one in which the observer and the observed need not be the same person. When they must be identical, I call the study subjective. For the present, we are concerned with what is required for understanding knowledge as an objective phenomenon. We shall take up the question of the subjective study of knowledge at a later stage. The scientific study of learning in animals is a very recent growth. It may almost be regarded as beginning with Thorndike's Animal Intelligence, which was published in 1911. Thorndike invented the method which has been adopted by practically all subsequent American investigators. In this method, an animal is separated from food, which he can see or smell, by an obstacle, which he may overcome by chance. A cat, say, is put in a cage having a door with a handle, which he may, by chance, push open with his nose. At first, the cat makes entirely random movements, until he gets his result by a mere fluke. On the second occasion, in the same cage, he still makes some random movements, but not so many as on the first occasion. On the third occasion, he does still better, and before long he makes no useless movements. Nowadays, it has become customary to employ rats instead of cats, and to put them in a model of the Hampton Court maze rather than in a cage. They take all sorts of wrong turnings at first, but after a time they learn to run straight out without making any mistake. Dr. Watson gives averages for 19 rats, each of which was put into the maze repeatedly, with food outside where the rat could smell it. In all the experiments, care was taken to make sure that the animal was very hungry. Dr. Watson says, the first trial required, on the average, over 17 minutes. During this time, the rat was running around the maze, into blind alleys, running back to the starting point, starting for the food again, biting at the wires around him, scratching himself, smelling this spot and that on the floor. Finally, he got to the food. He was allowed only a bite. Again, he was put back into the maze. The taste of the food made him almost frantic in his activity. He dashed about more rapidly. The average time for the group on this second trial is only a little over 7 minutes. On the fourth trial, not quite 3 minutes. From this point to the 23rd trial, the improvement is very gradual. On the 30th trial, the time required, on the average, was about 30 seconds. Watson, Behaviorism, pages 169-70. This set of experiments may be taken as typical of the whole group of studies to which it belongs. Thorndike, as a result of experiments with cages and mazes, formulated two provisional laws, which are as follows. The law of effect is that, of several responses made to the same situation, those which are accompanied or closely followed by satisfaction to the animal will, other things being equal, be more firmly connected with the situation, so that, when it recurs, they will be more likely to recur. Those which are accompanied or closely followed by dissatisfaction to the animal will, other things being equal, have their connections with that situation weakened, so that, when it recurs, they will be less likely to recur. The greater the satisfaction or discomfort, the greater the strengthening or weakening of the bond. The law of exercise is that any response to a situation will, other things being equal, be more strongly connected with the situation in proportion to the number of times it has been connected with that situation, and to the average vigor and duration of the connections. We may sum up these two laws, roughly, in the two statements. First, an animal tends to repeat what has brought it pleasure. Second, an animal tends to repeat what has often been done before. Neither of these laws is at all surprising, but as we shall see, there are difficulties in the theory that they are adequate to account for the process of learning in animals. Before going further, there is a theoretical point to be cleared up. Thorndike, in his first law, speaks of satisfaction and discomfort, which are terms belonging to subjective psychology. We cannot observe whether an animal feels satisfaction or feels discomfort. We can only observe that it behaves in ways that we have become accustomed to interpret as signs of these feelings. Thorndike's law, as it stands, does not belong to objective psychology and is not capable of being experimentally tested. This, however, is not so serious an objection as it looks. Instead of speaking of a result that brings satisfaction, we can merely enumerate the results which, in fact, have the character which Thorndike mentions, namely, that the animal tends to behave so as to make them recur. The rat in the maze behaves so as to get the cheese, and when an act has led him to the cheese once, he tends to repeat it. We may say that this is what we mean when we say that the cheese gives satisfaction, or that the rat desires the cheese. That is to say, we may use Thorndike's law of effect to give us an objective definition of desire, satisfaction, and discomfort. The law should then say, there are situations such that animals tend to repeat acts which have led to them. These are the situations which the animal is said to desire, and in which it is said to find satisfaction. This objection to Thorndike's first law is therefore not very serious, and need not further trouble us. Dr. Watson considers one principle alone sufficient to account for all animal and human learning, namely the principle of learned reactions. This principle may be stated as follows. When the body of an animal or human being has been exposed sufficiently often to two roughly simultaneous stimuli, The earlier of them alone tends to call out the response previously called out by the other. Although I do not agree with Dr. Watson in thinking this principle alone sufficient, I do agree that it is a principle of very great importance. It is the modern form of the principle of association. The association of ideas has played a great part in philosophy, particularly in British philosophy, but it now appears that this is a consequence of a wider and more primitive principle, namely the association of bodily processes. It is this wider principle that is asserted above. Let us see what is the nature of the evidence in its favor. Our principle becomes verifiable over a much larger field than the older principle, owing to the fact that it is movements, not ideas, that are to be associated. Where animals are concerned, ideas are hypothetical, but movements can be observed. Even with men, many movements are involuntary and unconscious. Yet animal movements and unconscious involuntary human movements are just as much subject to the law of association as the most conscious ideas. Take, e.g., the following example. Watson, page 33. The pupil of the eye expands in darkness and contracts in bright light. This is an involuntary and unconscious action of which we only become aware by observing others. Now, take some person and repeatedly expose him to bright light at the same moment that you ring an electric bell. After a time, the electric bell alone will cause his pupils to contract. As far as can be discovered, all muscles behave in this way. So do glands where they can be tested. It is said that a brass band can be reduced to silence by sucking a lemon in front of it, owing to the effect upon the salivary glands of its members. I confess that I have never verified this statement. But you will find the exact scientific analog for dogs in Watson, page 26. You arrange a tube in a dog's mouth so that saliva drops out at a measurable rate. When you give the dog food, it stimulates the flow of saliva. At the same moment, you touch his left thigh. After a certain length of time, the touch on the left thigh will produce just as much saliva without the food as with it. The same sort of thing applies to emotions, which depend upon the ductless glands. Children at birth are afraid of loud noises, but not of animals. Watson took a child, 11 months old, who was fond of a certain white rat. Twice, at the moment when the child touched the rat, a sudden noise was made just behind the child's head. This was enough to cause fear of the rat on subsequent occasions, no doubt owing to the fact that the adrenal gland was now stimulated by the substitute stimulus, just like the salivary glands in the dog or the trumpet player. The above illustrations show that ideas are not the essential units in association. It seems that not merely is mind irrelevant, but even the brain is less important than was formerly supposed. At any rate, what is known experimentally is that the glands and muscles, both striped and unstriped, of the higher animals, exhibit the law of transfer of response, i.e., when two stimuli have often been applied together, one will ultimately call out the response which formerly the other called out. This law is one of the chief bases of habit. It is also obviously essential to our understanding of language. The sight of a dog calls up the word dog, and the word dog calls up some of the responses appropriate to a real dog. There is, however, another element in learning besides mere habit. This is the element dealt with by Thorndike's law of effect. Animals tend to repeat acts which have pleasant consequences and to avoid such as have unpleasant consequences. But, as we saw a moment ago, pleasant and unpleasant are words which we cannot verify by objective observation. What we can verify by observation is that an animal seeks situations which, in fact, have had certain results, and avoid situations which, in fact, have had certain other results. Moreover, broadly speaking, the animal seeks results which tend to survival of itself or its offspring, and avoids results which tend in the opposite direction. This, however, is not invariable. Moths seek flames, and men seek drink, though neither is by biologically useful. It is only approximately, in situations long common, that animals are so adjusted to their environment as to act in a way which is advantageous from a biological standpoint. In fact, biological utility must never be employed as an explanation, but only noticed as a frequent characteristic of the ways in which animals behave. Dr. Watson is of the opinion that Thorndike's law of effect is unnecessary. He first suggests that only two factors are called for in the explanation of habit, namely, frequency and recency. Frequency is covered by Thorndike's law of exercise, but recency, which is almost certainly a genuine factor, is not covered by Thorndike's two laws. That is to say, when a number of random movements have finally resulted in success, the more recent of these movements are likely to be repeated earlier on a second trial than the earlier ones. But Dr. Watson finally abandons this method of dealing with habit formation in favor of the one law of conditioned reflexes, or learned reactions. He says, Behaviorism, page 166, only a few psychologists have been interested in the problem. Most of the psychologists, it is to be regretted, have even failed to see that there is a problem. They believe habit formation is implanted by kind fairies. For example, Thorndike speaks of pleasure stamping in the successful movement, and displeasure stamping out the unsuccessful movements. Most of the psychologists talk too, quite volubly, about the formation of new pathways in the brain, as though there were a group of tiny servants of Vulcan there, who run through the nervous system with hammer and chisel, digging new trenches and deepening old ones. I am not sure that the problem, when phrased in this way, is a soluble one. I feel that there must come some simpler way of envisaging the whole process of habit formation, or else it may remain insoluble. Since the advent of the conditioned reflex hypothesis in psychology, with all these simplifications, and I am often fearful that it may be an oversimplification, I have had my own laryngeal processes, i.e., what others call thoughts, stimulated to work upon this problem from another angle. I agree with Dr. Watson that the explanations of habit formation which are usually given are very inadequate, and that few psychologists have realized either the importance or the difficulty of the problem. I agree also that a great many cases are covered by his formula of the conditioned reflex. He relates a case of a child who once touched a hot radiator, and afterward avoided it for 2 years. He adds, if we should keep our old habit terminology, we should have in this example a habit formed by a single trial. There can be, then, in this case, no stamping in of the successful movement, and no stamping out of the unsuccessful movement. On the basis of such examples, he believes that the whole of habit formation can be derived from the principle of the conditioned reflex, which he formulates as follows, page 168. Stimulus X will not now call out reaction R. Stimulus Y will call out reaction R. Unconditioned reflex. But when stimulus X is presented first, and then Y, which does call out R, shortly thereafter, X will thereafter call out R. In other words, stimulus X becomes ever thereafter substituted for Y. This law is so simple, so important, and so widely true that there is a danger lest its scope should be exaggerated, just as in the 18th century, physicists tried to explain everything by means of gravitation. But when considered as covering all the ground, it seems to me to suffer from two opposite defects. In the first place, there are cases where no habit is set up, although by the law it should be. In the second place, there are habits which, so far as we can see at present, have a different genesis. To take the first point first, the word pepper does not make people sneeze, though according to the law, it should. Footnote. Dr. Watson apparently entertains hopes of teaching babies to sneeze when they see the pepper box, but he has not yet done so. See Behaviorism, page 90. End footnote. Words which describe succulent foods will make the mouth water. Voluptuous words will have some of the effect that would be produced by the situation they suggest, but no words will produce sneezes or the reactions appropriate to tickling. In the diagram given by Dr. Watson, page 106, there are 4 reflexes which appear to be not sources of conditioned reflexes, namely sneezing, hiccuping, blinking, and the Babinski reflex. Of these, however, blinking, it is suggested, page 99, may be really itself a conditioned reflex. There may be some quite straightforward explanation of the fact that some reactions can be produced by substitute stimuli while others cannot, but none is offered. Therefore, the law of the conditioned reflex, as formulated, is too wide, and it is not clear what is the principle according to which its scope should be restricted. The second objection to Dr. Watson's law of habit, if valid, is more important than the first, but its validity is more open to question. It is contended that the acts by which solutions of problems are obtained are, in cases of a certain kind, not random acts leading to success by mere chance, but acts proceeding from insight involving a mental solution of the problem as a preliminary to the physical solution. This is especially the view of those who advocate gestalt psychology, or the psychology of configuration. We may take, as typical of their attitude on the subject of learning, Köhler's mentality of apes. Köhler went to Tenerife with certain chimpanzees in the year 1913. Owing to the war, he was compelled to remain with them until 1917, so that his opportunities for study were extensive. He complains of the maze and cage problems set by American investigators, that they are such as cannot be solved by intelligence. Sir Isaac Newton himself could not have got out of the Hampton Court maze by any method except trial and error. Köhler, on the other hand, sets his apes problems which could be solved by what he calls insight. He would hang up a banana, footnote, called by Köhler the objective, because the word banana is too humble for a learned work. The pictures disclose the fact that the objective was a mere banana, end footnote, out of reach, and leave boxes in the neighborhood, so that by standing on the boxes, the chimpanzees could reach the fruit. Sometimes they had to pile 3 or even 4 boxes on top of each other before they could achieve success. Then he would put the banana outside the bars of the cage, leaving a stick inside, and the ape would get the banana by reaching for it with the stick. On one occasion, one of them, named Sultan, had 2 bamboo sticks, each too short to reach the banana. After vain efforts, followed by a period of silent thought, he fitted the smaller into the hollow of the other, and so manufactured one stick which was long enough. It seems, however, from the account, that he first fitted the 2 together more or less accidentally, and only then realized that he had found a solution. Nevertheless, his behavior when he had once realized that one stick could be made by joining the 2 was scarcely Watsonian. There was no longer anything tentative, but a definite triumph, first in anticipation, and then in action. He was so pleased with his new trick that he drew a number of bananas into his cage before eating any of them. He behaved, in fact, as capitalists have behaved with machinery. Köhler says, we can, from our own experience, distinguish sharply between the kind of conduct which, from the very beginning, arises out of a consideration of the characteristics of a situation, and one that does not. Only in the former case do we speak of insight, and only that behavior of animals definitely appears to us intelligent, which takes account from the beginning of the lie of the land, and proceeds to deal with it in a smooth, continuous course. Hence follows this characteristic, to set up as the criterion of insight the appearance of a complete solution with reference to the whole layout of the field. Genuine solutions of problems, Köhler says, do not improve by repetition. They are perfect on the first occasion, and if anything, grow worse by repetition when the excitement of discovery is worn off. The whole account that Köhler gives of the efforts of his chimpanzees makes a totally different impression from that of the rats in mazes, and one is forced to conclude that the American work is somewhat vitiated by confining itself to one type of problem and drawing from that one type conclusions which it believes to be applicable to all problems of animal learning. It seems that there are two ways of learning, one by experience and the other by what Köhler calls insight. Learning by experience is possible to most vertebrates, though rarely, so far as is known, to invertebrates. Learning by insight, on the contrary, is not known to exist in any animals lower than the anthropoid apes, though it would be extremely rash to assert that it will not be revealed by further observations on dogs or rats. Unfortunately, some animals, for instance elephants, may be extremely intelligent, but the practical difficulty and expense of experimentation with them is so great that we are not likely to know much about them for some time to come. However, the real problem is already sufficiently definite in Köhler's book. It is the analysis of insight as opposed to the method of the conditioned reflex. Let us first be clear as to the nature of the problem when described solely in terms of behavior. A hungry monkey, if sufficiently near to a banana, will perform acts such as, in circumstances to which it has been accustomed, have previously enabled it to obtain bananas. This fits well with either Watson or Thorndike, so far. But if these familiar acts fail, the animal will, if it has been long without food, is in good health, and is not too tired, proceed to other acts which have never hitherto produced bananas. One may suppose, if one wishes to follow Watson, that these new acts are composed of a number of parts, each of which, on some former occasion, has occurred in a series which ended up with the obtaining of the banana. Or one may suppose, as I think Thorndike does, that the acts of the baffled animal are random acts, so that the solution emerges by pure chance. But even in the first hypothesis, the element of chance is considerable. Let us suppose that the acts A, B, C, D, E have each, on a former occasion, been part of a series ending with success, but that now, for the first time, it is necessary to perform them all, and in the right order. It is obvious that if they are only combined by chance, the animal will be lucky if it performs them all in the right order before dying of hunger. But Köhler maintains that to anyone watching his chimpanzees, it was obvious that they did not obtain the composition of the solution out of chance parts. He says, pages 199-200, it is certainly not a characteristic of the chimpanzee, when he is brought into an experimental situation, to make any chance movements, out of which, among other things, a non-genuine solution could arise. He is very seldom seen to attempt anything which would have to be considered accidental in relation to the situation, excepting, of course, if his interest is turned away from the objective to other things. As long as his efforts are directed to the objective, all distinguishable stages of his behavior, as with human beings in similar situations, tend to appear as complete attempts at solutions, none of which appears as the product of accidentally arrayed parts. This is true, most of all, of the solution which is finally successful. Certainly, it often follows upon a period of perplexity or quiet, often a period of survey. But in real and convincing cases, the solution never appears in a disorder of blind impulses. It is one continuous smooth action, which can be resolved into its parts only by the imagination of the onlooker. In reality, they do not appear independently. But that in so many genuine cases as have been described, these solutions as wholes should have arisen from mere chance, is an entirely inadmissible supposition. Thus, we may take it as an observed fact that, so far as overt behavior is concerned, there are two objections to the type of theory with which we began, when considered as covering the whole field. The first objection is that, in cases of a certain kind, the solution appears sooner than it should, according to the doctrine of chances. The second is that it appears as a whole, i.e., that the animal, after a period of quiescence, suddenly goes through the right series of actions smoothly and without hesitation. Where human beings are concerned, It is difficult to obtain such good data as in the case of animals. Human mothers will not allow their children to be starved and then shut up in a room containing a banana which can only be reached by putting a chair on the table and a footstool on the chair, and then climbing up without breaking any bones. Nor will they permit them to be put into the middle of a Hampton Court maze, with their dinner getting cold outside. Perhaps in time the state will perform these experiments with the children of political prisoners, but as yet, perhaps fortunately, the authorities are not sufficiently interested in science. One can observe, however, that human learning seems to be of both sorts, namely that described by Watson and that described by Köhler. I am persuaded that speech is learnt by the Watsonian method, so long as it is confined to single words. Often the trial and error, in later stages, proceeds sotto voce, but it takes place overtly at first, and in some children until their speech is quite correct. The speaking of sentences, however, is already more difficult to explain without bringing in the apprehension of wholes, which is the thing upon which Gestalt psychology lays stress. In the later stages of learning, the sort of sudden illumination which came to Köhler's chimpanzees is a phenomenon with which every serious student must be familiar. One day, after a period of groping bewilderment, the schoolboy knows what algebra is all about. In writing a book, my own experience, which I know is fairly common, though by no means universal, is that for a time I fumble and hesitate, and then suddenly I see the book as a whole, and have only to write it down as if I were copying a completed manuscript. If these phenomena are to be brought within the scope of behaviorist psychology, it must be by means of implicit behavior. Watson makes much use of this in the form of talking to oneself, but in apes it cannot take quite this form, and it is necessary to have some theory to explain the success of implicit behavior, whether we call it thought or not. Perhaps such a theory can be constructed on Watson's lines, but it has certainly not yet been constructed. Until the behaviorists have satisfactorily explained the kind of discovery which appears in Köhler's observations, we cannot say that their thesis is proved. This is a matter which will occupy us again at a later stage. For the present, let us preserve an open mind. End of chapter 3. Chapter 4 of Philosophy by Bertrand Russell. This LibriVox recording is in the public domain. Language. The subject of language is one which has not been studied with sufficient care in traditional philosophy. It was taken for granted that words exist to express thoughts, and generally also that thoughts have objects, which are what the words mean. It was thought that by means of language we could deal directly with what it means, and that we need not analyze with any care either of the two supposed properties of words, namely that of expressing thoughts and that of meaning things. Often when philosophers intended to be considering the objects meant by words, they were, in fact, considering only the words, and when they were considering words, they made the mistake of supposing, more or less unconsciously, that a word is a single entity, not, as it really is, a set of more or less similar events. The failure to consider language explicitly has been a cause of much that was bad in traditional philosophy. I think myself that meaning can only be understood if we treat language as a bodily habit, which is learned just as we learn football or bicycling. The only satisfactory way to treat language, to my mind, is to treat it in this way, as Dr. Watson does. Indeed, I should regard the theory of language as one of the strongest points in favor of behaviorism. Man has various advantages over the beasts, for example, fire, clothing, agriculture, and tools, not the possession of domestic animals, for ants have them. But more important than any of these is language. It is not known how or when language arose, nor why chimpanzees do not speak. I doubt if it is even known whether writing or speech is the older form of language. The pictures made in caves by the Cro-Magnon men may have been intended to convey a meaning, and may have been a form of writing. It is known that writing developed out of pictures, for that happened in historical times. But it is not known to what extent pictures had been used in prehistoric times as a means of giving information or commands. As for spoken language, it differs from the cries of animals in being not merely an expression of emotion. Animals have cries of fear, cries expressing pleasure in the discovery of food, and so on. And by means of these cries, they influence each other's actions. But they do not appear to have any means of expressing anything except emotions, and then only emotions which they are actually feeling. There is no evidence that they possess anything analogous to narrative. We may say, therefore, without exaggeration, that language is a human prerogative, and probably the chief habit in which we are superior to the dumb animals. There are three matters to be considered in beginning the study of language. First, what words are, regarded as physical occurrences. Secondly, what are the circumstances that lead us to use a given word. Thirdly, what are the effects of our hearing or seeing a given word. But as regards the second and third of these questions, we shall find ourselves led on from words to sentences, and thus confronted with fresh problems, perhaps demanding, rather, the methods of Gestalt psychology. Ordinary words are of four kinds: spoken, heard, written, and read. It is, of course, largely a matter of convention that we do not use words of other kinds. There is the deaf and dumb language. A Frenchman's shrug of the shoulders is a word. In fact, any kind of externally perceptible body movement may become a word, if social usage so ordains. But the convention which has given the supremacy to speaking is one which has a good ground, since there is no other way of producing a number of perceptibly different bodily movements so quickly or with so little muscular effort. Public speaking would be very tedious if statesmen had to use the deaf and dumb language, and very exhausting if all words involved as much muscular effort as a shrug of the shoulders. I shall ignore all forms of language except speaking, hearing, writing, and reading, since the others are relatively unimportant and raise no special psychological problems. A spoken word consists of a series of movements in the larynx and the mouth, combined with breath. Two closely similar series of such movements may be instances of the same words, though they may not be, since two words with different meanings may sound alike, but two such series which are not closely similar cannot be instances of the same word. I am confining myself to one language. Thus, a single spoken word, say, dog, is a certain set of closely similar series of bodily movements, the set having as many members as there are occasions when the word dog is pronounced. The degree of similarity required in order that the occurrence should be an instance of the word dog cannot be specified exactly. Some people say dog, and this must certainly be admitted. A German might say talk, and then we should begin to be doubtful. In marginal cases, we cannot be sure whether a word has been pronounced or not. A spoken word is a form of bodily behavior without sharp boundaries, like jumping or hopping or running. Is a man running or walking? In a walking race, the umpire may have great difficulty in deciding. Similarly, there may be cases where it cannot be decided whether a man has said dog or dock. A spoken word is thus at once general and somewhat vague. We usually take for granted the relation between a word spoken and a word heard. Can you hear what I say? We ask, and the person addressed says yes. This is, of course, a delusion, a part of the naive realism of our unreflective outlook on the world. We never hear what is said. We hear something having a complicated causal connection with what is said. There is, first, the purely physical process of sound waves from the mouth of the speaker to the ear of the hearer, then a complicated process in the ear and nerves, and then an event in the brain, which is related to our hearing of the sound in a manner to be investigated later, but is, at any rate, simultaneous with our hearing of the sound. This gives the physical causal connection between the word spoken and the word heard. There is, however, also another connection of a more psychological sort. When a man utters a word, he also hears it himself, and so that the word spoken and the word heard become intimately associated for anyone who knows how to speak. And a man who knows how to speak can also utter any word he hears in his own language, so that the association works equally well both ways. It is because of the intimacy of this association that the plain man identifies the word spoken with the word heard, although in fact the two are separated by a wide gulf. In order that speech may serve its purpose, it is not necessary, as it is not possible, that heard and spoken words should be identical. But it is necessary that when a man utters different words, the heard words should be different, and when he utters the same word on two occasions, the heard words should be approximately the same on the two occasions. The first of these depends upon the sensitiveness of the ear and its distance from the speaker. We cannot distinguish between two rather similar words if we are too far off from the man who utters them. The second condition depends upon uniformity in the physical conditions, and is realized in all ordinary circumstances. But if the speaker were surrounded by instruments which were resonant to certain notes but not to certain others, some tones of voice might carry and others might be lost. In that case, if he uttered the same word with two different intonations, the hearer might be quite unable to recognize the sameness. Thus, the efficacy of speech depends upon a number of physical conditions. These, however, we will take for granted in order to come as soon as possible to the more psychological parts of our topic. Written words differ from spoken words in being material structures. A spoken word is a process in the physical world, having an essential time order. A written word is a series of pieces of matter, having an essential space order. As to what we mean by matter, that is a question with which we shall have to deal at length at a later stage. For the present, it is enough to observe that the material structures which constitute written words, unlike the processes that constitute spoken words, are capable of enduring for a long time, sometimes for thousands of years. Moreover, they are not confined to one neighborhood, but can be made to travel about the world. These are the two great advantages of writing over speech. This, at least, has been the case until recently. But with the coming of radio writing, it has begun to lose its preeminence. One man can now speak to multitudes spread over a whole country. Even in the matter of permanence, speech may become the equal of writing. Perhaps, instead of legal documents, we shall have gramophone records with voice signatures by the parties to the contract. Perhaps, as in When the Sleeper Awakes, books will no longer be printed, but merely arranged for the gramophone. In that case, the need for writing may almost cease to exist. However, let us return from these speculations to the world of the present day. The word read, as opposed to the written or printed word, is just as evanescent as the word spoken or heard. Whenever a written word, exposed to light, is in a suitable spatial relation to a normal eye, it produces a certain complicated effect upon the eye. The part of this process which occurs outside the eye is investigated by the science of light, whereas the part that occurs in the eye belongs to physiological optics. There is then a further process, first in the optic nerve and afterwards in the brain. The process in the brain is simultaneous with vision. What further relation it has to vision is a question as to which there has been much philosophical controversy. We shall return to it at a later stage. The essence of the matter, as regards the causal efficacy of writing, is that the act of writing produces quasi-permanent material structures which, throughout the whole of their duration, produce closely similar results upon all suitably placed normal eyes. And, as in the case of speaking, different written words lead to different read words, and the same word written twice leads to the same read word, again with obvious limitations. So much for the physical side of language, which is often unduly neglected. I come now to the psychological side, which is what really concerns us in this chapter. The two questions we have to answer, apart from the problems raised by sentences as opposed to words, are, first, what sort of behavior is stimulated by hearing a word? And secondly, what sort of occasion stimulates us to the behavior that consists in pronouncing a word? I put the questions in this order because children learn to react to the words of others before they learn to use words themselves. It might be objected that in the history of the race, the first spoken word must have preceded the first heard word, at least by a fraction of a second. But this is not very relevant, nor is it certainly true. A noise may have meaning to the hearer, but not to the utterer. In that case, it is a heard word, but not a spoken word. I shall explain what I mean by meaning shortly. Friday's footprint had meaning for Robinson Crusoe, but not for Friday. However that may be, we shall do better to avoid the very hypothetical parts of anthropology that would be involved, and take up the learning of language as it can be observed in the human infant of the present day. And in the human infant, as we know him, definite reactions to the words of others come much earlier than the power of uttering words himself. A child learns to understand words exactly as he learns any other process of bodily association. If you always say bottle when you give a child his bottle, he presently reacts to the word bottle, within limits, as he formerly reacted to the bottle. This is merely an example of the law of association which we considered in the preceding chapter. When the association has been established, parents say that the child understands the word bottle, or knows what the word means. Of course, the word does not have all the effects that the actual bottle has. It does not exert gravitation. It does not nourish. It cannot bump onto the child's head. The effects, which are shared by the word and the thing, are those which depend upon the law of association, or conditional reflexes, or learned reactions. These may be called associative effects, or mnemic effects, the latter name being derived from Siemens' work, Mneme, in which he traces all phenomena analogous to memory to a law which is, in effect, not very different from the law of association or conditioned reflexes. It is possible to be a little more precise as to the class of effects concerned. A physical object is a center from which a variety of causal chains emanate. If the object is visible to John Smith, one of the causal chains emanating from it consists first of light waves, or light quanta, which travel from the object to John Smith's eye, then of events in his eye and optic nerve, then of events in his brain, and then, perhaps, of a reaction on his part. Now, mnemic effects belong only to events in living tissue. Therefore, only those effects of the bottle which happen either inside John Smith's body or as a result of his reaction to the bottle can become associated with his hearing the word bottle. And even then, only certain events can be associated. Nourishment happens in the body, yet the word bottle cannot nourish. The law of conditioned reflexes is subject to ascertainable limitations, but within its limits, it supplies what is wanted to explain the understanding of words. The child becomes excited when he sees the bottle. This is already a conditioned reflex due to experience that this sight precedes a meal. One further stage in conditioning makes the child grow excited when he hears the word bottle. He is then said to understand the word. We may say then that a person understands a word which he hears if, so far as the law of conditioned reflexes is applicable, the effects of the word are the same as those of what it is said to mean. This, of course, only applies to words like bottle, which denote some concrete object or some class of concrete objects. To understand a word such as reciprocity or republicanism is a more complicated matter, and cannot be considered until we have dealt with sentences. But before considering sentences, we have to examine the circumstances which make us use a word, as opposed to the consequences of hearing it used. Saying a word is more difficult than using it, except in the case of a few simple sounds which infants make before they know that they are words, such as mama and dada. These two are among the many random sounds that all babies make. When a child says mama in the presence of his mother by chance, she thinks he knows what this noise means, and she shows pleasure in ways that are agreeable to the infant. Gradually, in accordance with Thorndike's law of effect, he acquires the habit of making this noise in the presence of his mother, because in these circumstances the consequences are pleasant. But it is only a very small number of words that are acquired in this way. The great majority of words are acquired by imitation, combined with the association between thing and word, which the parents deliberately establish in the early stages, after the very first stage. It is obvious that using words oneself involves something over and above the association between the sound of the word and its meaning. Dogs understand many words, and infants understand far more than they can say. The infant has to discover that it is possible and profitable to make noises like those which he hears. This statement must not be taken quite literally, or it would be too intellectualistic. He would never discover this if he did not make noises at random without the intention of talking. He then gradually finds that he can make noises like those which he hears, and in general the consequences of doing so are pleasant. Parents are pleased, desired objects can be obtained, and perhaps most important of all, there is a sense of power in making intended instead of accidental noises. But in this whole process, there is nothing essentially different from the learning of mazes by rats. It resembles this form of learning rather than that of killer apes, because no amount of intelligence could enable the child to find out the names of things. As in the case of mazes, experience is the only possible guide. When a person knows how to speak, the conditioning proceeds in the opposite direction to that which operates in understanding what others say. The reaction of a person who knows how to speak when he notices a cat is naturally to utter the word cat. He may not actually do so, but he will have a reaction leading towards this act, even if for some reason the overt act does not take place. It is true that he may utter the word cat because he is thinking about a cat, not actually seeing one. This, however, as we shall see in a moment, is merely one further stage in the process of conditioning. The use of single words as opposed to sentences is wholly explicable, so far as I can see, by the principles which apply to animals in mazes. Certain philosophers who have a prejudice against analysis contend that the sentence comes first and the single word later. In this connection, they always allude to the language of the Patagonians, which their opponents, of course, do not know. We are given to understand that a Patagonian can understand you if you say, "I am going to fish in the lake behind the western hill," but that he cannot understand the word fish by itself. This instance is imaginary, but it represents the sort of thing that is asserted. Now, it may be that Patagonians are peculiar. Indeed, they must be, or they would not choose to live in Patagonia. But certainly infants in civilized countries do not behave in this way, with the exception of Thomas Carlyle and Lord Macaulay. The former never spoke before the age of 3, when, hearing his younger brother cry, he said, "What ails wee Jock?" Lord Macaulay learned in suffering what he taught in song, for, having spilt a cup of hot tea over himself at a party, he began his career as a talker by saying to his hostess, after a time, "Thank you, madam, the agony is abated." These, however, are facts about biographers, not about the beginnings of speech in infancy. In all children that have been carefully observed, sentences come much later than single words. Children, at first, are limited as to their power of producing sounds, and also by the paucity of their learned associations. I am sure the reason why Mama and Dada have the meaning they have is that they are sounds which infants make spontaneously at an early age, and are therefore convenient as sounds to which the elders can attach meaning. In the very beginning of speech, there is not imitation of grown-ups, but the discovery that sounds made spontaneously have agreeable results. Imitation comes later, after the child has discovered that sounds can have this quality of meaning. The type of skill involved is throughout exactly similar to that involved in learning to play a game or ride a bicycle. We may sum up this theory of meaning in a simple formula. When, through the law of conditioned reflexes, A has come to be a cause of C, we will call A an associative cause of C, and C an associative effect of A. We shall say that to a given person, the word A, when he hears it, means C, if the associative effects of A are closely similar to those of C. And we shall say that the word A, when he utters utters it means C, if the utterance of A is an associative effect of C, or if something previously associated with C. To put the matter more concretely, the word Peter means a certain person if the associated effects of hearing the word Peter are closely similar to those of seeing Peter, and the associative causes of uttering the word Peter are occurrences previously associated with Peter. Of course, as our experience increases in complexity, this simple schema becomes obscured and overlaid, but I think it remains fundamentally true. There is an interesting and valuable book by Messrs. C.K. Ogden and I.A. Richards called The Meaning of Meaning. This book, owing to the fact that it concentrates on the causes of uttering words, not on the effects of hearing them, gives only half the above theory, and that in a somewhat incomplete form. It says that a word and its meaning have the same causes. I should distinguish between active meaning, that of the man uttering the word, and passive meaning, that of the man hearing the word. In active meaning, the word is associatively caused by what it means or is something associated with this. In passive meaning, the associative effects of the word are approximately the same as those of what it means. On behaviorist lines, there is no important difference between proper names and what are called abstract or generic words. A child learns to use the word cat, which is general, just as he learns to use the word Peter, which is a proper name. But in actual fact, Peter really covers a number of different occurrences, and is, in a sense, general. Peter may be near or far, walking or standing or sitting, laughing or frowning. All these produce different stimuli, but the stimuli have enough in common to produce the reaction consisting of the word Peter. Thus there is no essential difference, from a behaviorist point of view, between Peter and man. There are more resemblances between the various stimuli to the word Peter than between those to the word man, but this is only a difference of degree. We have not names for the fleeting particular occurrences which make up the several appearances of Peter, because they are not of much practical importance. Their importance, in fact, is purely theoretic and philosophical. As such, we shall have a good deal to say about them at a later stage. For the present, we notice that there are many occurrences of Peter, and many occurrences of the word Peter. Each, to the man who sees Peter, is a set of events having certain similarities. More exactly, the occurrences of Peter are causally connected, whereas the occurrences of the word Peter are connected by similarity. But this is a distinction which need not concern us yet. General words such as man, or cat, or triangle are said to denote universals, concerning which, from the time of Plato to the present day, philosophers have never ceased to debate. Whether there are universals, and if so, in what sense, is a metaphysical question, which need not be raised in connection with the use of language. The only point about universals that needs to be raised at this point is that the correct use of general words is no evidence that a man can think about universals. It has often been supposed that because we can use a word like man correctly, we must be capable of a corresponding abstract idea of man. But this is quite a mistake. Some reactions are appropriate to one man, some to another, but all have certain elements in common. If the word man produces in us the reactions which are common, but no others, we may be said to understand the word man. In learning geometry, one acquires the habit of avoiding special interpretations of such a word as triangle. We know that when we have a proposition about triangles in general, we must not think specially of a right-angled triangle, or any one kind of triangle. This is essentially the process of learning to associate with the word what is associated with all triangles. When we have learned this, we understand the word triangle. Consequently, there is no need to suppose that we ever apprehend universals, although we use general words correctly. Hitherto, we have spoken of single words, and among these we have considered only those that can naturally be employed singly. A child uses single words of a certain kind before constructing sentences, but some words presuppose sentences. No one would use the word paternity until after using such sentences as, John is the father of James. No one would use the word causality until after using such sentences as, "The fire makes me warm." Sentences introduce new considerations and are not quite so easily explained on behaviorist lines. Philosophy, however, imperatively demands an understanding of sentences, and we must therefore consider them. As we found earlier, all infants outside Patagonia begin with single words and only achieve sentences later. But they differ enormously in the speed with which they advance from one to the other. My own two children adopted entirely different methods. My son first practiced single letters, then single words, and only achieved correct sentences of more than 3 or 4 words at the age of 2 and 3 months. My daughter, on the contrary, advanced very quickly to sentences in which there was hardly ever an error. At the age of 18 months, when supposed to be sleeping, she was overheard saying to herself, "Last year I used to dive off the diving board. I did." Of course, "last year" was merely a phrase repeated without understanding. And no doubt the first sentences used by children are always repetitions, unchanged, of sentences they have heard used by others. Such cases raise no new principle not involved in the learning of words. What does raise a new principle is the power of putting together known words into a sentence which has never been heard, but which expresses correctly what the infant wishes to convey. This involves the power to manipulate form and structure.
Oh, hello, my dogs.
This does not, of course, involve the
Are you guys being
apprehension
good
of form
dogs?
or structure in the abstract, any more than the
You
use
guys
of the
being
word
good
matter
dogs?
involves apprehension of the universal. But it does involve a causal connection between the form of the stimulus
This is a
and the
good
form
boy,
of the
Jen.
reaction.
Good girl, Willa.
An infant
A
very
good boy,
soon
Jen.
learns to be differently affected by the statement
A good
cats
girl,
eat
Willa.
mice from the way he would be affected by the statement
Did it sound
mice
good
eat
now?
cats. And not much later, he learns to make one
And
of these
still
statements
was.
rather than the other. In such a case, the cause in hearing, or the effect in speaking, is a whole sentence. It may be that one part of the environment is sufficient to cause one word, while another is sufficient to cause another, but it is only the two parts in their relation that can cause the whole sentence. Thus, wherever sentences come in, we have a causal relation between two complex facts, namely the fact asserted and the sentence asserting it. The facts as wholes enter into the cause and effect relation, which cannot be explained wholly as compounded of relations between their parts. Moreover, as soon as the child has learned to use correctly relational words, such as eat, he has become capable of being causally affected by a relational feature of the environment, which involves a new degree of complexity not required for
Oh, thank God that's off. Jet, what are you sleeping on? Jet, can I have this? That can't be comfortable. I have it. Oh, it says no dogs allowed. Yeah, so much. She was. You should have a boys a lot. I make an appearance on the live. Simba, you're gonna knock over the camera. quite sure how your dad had this situated. Like that, maybe? Alright, Willa, cuddle up. Oh, that'll work too. The dogs are gonna get it. What? It's over there. Come on, Simba. Over here. Oh, sorry, Simba. I didn't mean to do that. Guys, who's home?
Babe, these dogs are so busy.
Look at Chet wagging his tail. Chet, you being a good boy. Is Chet a good boy? Chet, you're a good boy. Maybe I can clip a nail before he notices.
I'm tired.
Jet, are you being a good boy? Is Jet a good boy? Is Jet a good boy? Oh, no. Jet. Just one nail.
Oh, he said thanks so.
Yeah, he really said thanks, though.
Alright.
Salad?
Yep. Thanks though. Dude, the dogs want Bertrand Russell back on.
Is that what they said? Someone today was like, do you have any freeze-dried cheese? Treats for dog? Was it? No.
You got it. cheese than it used to be. I mean, I still want a reaction out of you, but it's close that you follow.
Got a little more good. Actually, look at Simba's. He's getting way too good at that. We might need to change up his enrichment. Maybe you can figure out a Snoopy Snoop. You're just so excited. Look at him. This is so exciting. Did you want some?
I want some.
Does Willow want some? They love peppers. Babe, we got Jet sitting up now. They're on alert. Well,
Mm-hmm. Do you think the dog still deserves to listen to Bertrand Russell?
say ahoo if you want to listen to Bertrand Russell.
Oh.
seemed like it put him to sleep earlier.
Dogs are supposed to sleep, babe. Dogs are supposed to sleep.
For like 16 to 18 hours a day. Got any cucumber? Does Jet want a cucumber? Does Jet want a cucumber? Does Willa want a cucumber? Does Willa want a cucumber? Good girl. You like those pepperinos? You think those are cozy?
Woof.
Alright, babe, I'm going to reflex.
Hold on.